What's up, kiddos? Hey, okay, you see an equation behind me that is a rational equation, where there's an equation that involves rational expressions. We just did this where there's one on either side. Remember, we use means extremes to solve it. Now, here's the difference between what we did in the last video to this video. You're going to be given an equation with rational expressions, but there's not going to be two of them. There's actually going to be three, or there could be four or more. We're really going to focus on three. So there might be two on the left side of the equation. There might be two on the right side. So for example, maybe it's going to look like this. I don't know. I'm just making it up. Something like that. And now, we're going to learn how we can solve this equation for x, that whatever number we put in for x will make the equation true. Whoa, this is going to be unbelievable. And oh yes, very joyful. So, oh joy, here we go. Okay, so that's the idea. Now I'm going to show you this. There's two ways to look at this. With these simple examples like we did in the last video, where you have an equation with an expression on this side and expression on that side, you can use cross products, means extremes. So you can take the 2 times the 18 and get this. You can take the 3 times the x and get that. And then solve it up by just simply, distributing like the next step had said. So we get 36 equals 3x, divided by 3, which gives you x equals 12. Over here on the right, though, when you see an equation that has rational expressions where there's more than 2, one on either side, you can't use cross products, because what would you do? You can't take 18 times 2 plus 1. You can't take 2 plus 3 times x. That's just as weird. But what you can do is something we've already learned with complex fractions and adding and subtracting rational expressions. You can actually take this side right here, if you wanted to, and get common denominators, like I did right here by multiplying by 3 over 3 and 2 over 2 to get 6 as my common denominator. And then when I add it together, that gives me 7, 6. Why would you do that? Because if you look, now I have an equation just like we did right there with 2 rational expressions, of which I can use means extremes to get my answer. So you could do 7 times 8, 6 times x, and then distribute, which gives you 126 equals 6x, which means x is 21. Both ways are great. They're phenomenal. Over here, that's the way that I told you in class that you should do these types of questions. Absolutely. Over here, I wouldn't recommend this, although it is an option. I'm going to teach you this method where you're going to use the least common denominator, and you're going to distribute that through the entire problem, which is going to clear some fractions, which is going to make a nice, easier equation for you. You'll see what I'm talking about. I did it right here. If you look at the original question, 2/3 and x over 18, 18 is actually my LCD. So if I took the LCD and I multiplied it to this first fraction, and I multiplied it to this fraction, what happens is the 18's here cross off, I'm left with x. Nice. And if I do it here, this reduces to a 1, and this reduces to a 6. So really I have 6 times 2, which just gives me a 12. Awesome. So it's the same answer, 12 and 12, just 2 different methods of doing it. Now check this out. Over here, I'm going to use the same method by using the LCD. My LCD up here in all of these 3 things is actually 18 again. So if I take that 18, the LCD, and distribute it through, take 18 times 1/2, take 18 times 2/3, and take 18 times this. I did it right here. 18 times that actually will cross reduce to a 9 over 1. So 9 times 1 is a 9. 1 times nothing, really just a 9. So over here, cross reduce this, that goes to a 1, this goes to a 6, so 6 times 2 is 12. Nice. And this here, 18 times 18, or the 18's crossed off, so that's a 1 over 1, so 1 times x is just x. Check this out. So 9 plus 12 is just 21, and I get the same answers. So what you actually see in a very simple example like this is when I multiply all the things by the LCD, it actually completely eliminates the fractions, and I'm just left with a very simple equation like this that I can easily solve. And you're going to see how cool that's going to be when we get to rational expressions or equations that involve rational expressions. They're called rational equations. So onto your graphic organizer, let's get your steps here of what I would recommend that you do to solve these equations when you are using the LCD. So steps to solving, and this is again is where you have an equation where you have 2 3 or more rational expressions. So 2 on one side and 1 on the other, or whatever. So first thing is to find the least common denominator of all, there's a key word, all of the rational expressions. Don't just do the left side, don't just do the right side. Do it all. All of the rational expressions, find the LCD of that. So that's step number 1. Step number 2, you're going to multiply all the rational expressions by the LCD. So the LCD you found here, take and multiply it to every one of the expressions, the rational expressions that's in your equation. Sweet. And what it means here is we're just really distributing the LCD to everything. And what's cool, what you see here in green, this actually clears the fractions. And it creates a nice, simple, solvable equation for you to do. So then step number 3 is just solve. And what you're probably going to have to do when you get to this step is you're probably going to have to distribute, maybe FOIL, who knows, maybe just distribute, whatever, and then you're going to have to collect your like terms. We talked about this a little bit in class, but collecting your like terms, I would probably do this first. Collect your like terms on the same side first. So if there's a whole bunch on the left side, put them together as much as you can. If there's a bunch on the right side, put them together as much as you can. And then when you have variables on either sides, continue combining your like terms, but move them all over to one side of the equation. Or go this way. Completely your choice. But just choose. Move them all to this side, or move them all to this side. So after you do that, then you're going to get your answer, solve it, you might have to factor it, whatever, but you want to make sure you then, again, check for extraneous solutions. So there's your 3 steps, a little bit more involved with number 3, but those are your 3 steps, mindset-wise, thought process-wise, to get through these questions. So let's do an example or 2. Okay, so move this aside, and here's the example. It's on your graphic organizer. So you see 4 over x minus 1 over x plus 2 equals 2 over x. Rational equation with more than 2 rational expressions. So step number 1, I must find my LCD. Well, here is one of my denominators. Here's another denominator. Here's the other denominator. My LCD then would have to include an x and another factor of x plus 2 and a factor of an x, but I already have it right here. So my LCD is that guy right there. Sweet. So what I must then do is step number 2. I take and multiply this LCD to every one of the 3 or 4, how many there are, all of the rational expressions that's in the equation. So that's what I did right here. X plus 2, that LCD is multiplied to that one, multiplied to that one, and multiplied to this one. Please notice, don't know if you did or not, I put parentheses around each of these rational expressions up here. It is subtraction, so you see the subtraction there. That's a very key thing. You don't have to. I'm going to recommend that you do it because it helps you stay organized. Because after you do that, and we distribute it through there, there's some things that actually cross off. Because technically I'm multiplying by x times x plus 1 over just a funky looking 1. Or not a funky looking 1, just a 1. So that's cool because now I can cross off the x and the x, and I'm left with 4 times the quantity of x plus 2. That's why I got it there. Over here, I have an x plus 2 on top and x plus 2 on the bottom, so they cross off. So really I'm just left with 1 times x, that's why it's right there. And it equals, over here, over 1. So really I have an x on top and an x on the bottom. They really cross each other off, so I'm left with 2 times the quantity of x plus 2. That's why it looks like that. So that is really step number 2. And then step number 3, as I just said, you got to solve it. So throughout all the steps, distribute first. So we distribute the 4 here, you get 4x plus 8. Great. This is 1 times x, phenomenal. You just get x. This gives you 2x plus 4. Awesome. And then again, this is the thing. I'd start combining like terms, but since I have some on the same side over here, the 4x and the negative x, I put those together first. And notice I have no more like terms on the left side. I have no more like terms on the right side, but I do have like terms on either side. So you need to make sure then you kind of do what you want to do. I don't care if you move the 2x over here or the 3x over here. Doesn't matter. If it was me, I'd keep things as positive as possible. I'm a positive person. You should be too. So negative 2, I would subtract the 2x, subtract the 2x. So that means here I'm left with an x. I would subtract an 8 to put that over on this side. So when I do that, I get x equals a negative 4. Bing! So there is my solution. Or is it? Check to see if it's an extraneous solution. So we see this negative 4. If I put it back in here, no problems there. Put it back in here, No problemo. Yeah. Put a negative 4 back in there. It's no problem, man. We got it. So there's nothing wrong with it, meaning it doesn't give us an error message. It doesn't give us 0 in the denominator. So that is a wonderful solution. So negative 4 works. And there's your answer. Let's go on to example number 2 on your graphic organizer. Same steps apply, guys. You're going to have to find the LCD of all 3 of these particular rational expressions. The difference in this one is the following. Notice that one right there is not a rational expression. Oh no! We skip it. We can't do it. Okay, come on. Here's what you do. It's simple. This is a rational expression. You just didn't write it like it's supposed to be yet. That doesn't make any sense. It's a rational expression. It just doesn't look like one yet. That's better. Because I can take this 3 and just put it over a 1. Oh! Now it looks like a rational expression because I had something on top and something on the bottom. Okay? And it's not really a rational expression because there's no variable in it, but understand the idea. So I'd rewrite this as just 3 over 1. So now, let's look and see if we got an LCD. I believe we do. Over here on the left, this denominator has an x minus 2, so I definitely need that as a factor in there. This is a factor of a 1. Well, you can write it up here, but this does you no good. And this is an x minus 2. We already have that. Sweet. So really, my LCD is just x minus 2. That's step 1. Step 2, multiply that LCD to everything that's in my equation. Distribute it through to everything. Put parentheses around this, bam, multiply it by x minus 2. Parentheses around this, bam, multiply it by x minus 2. Put parentheses around this, bam, multiply it by x minus 2. So then when I do that, this is a really cool question. So now, x minus 2 over 1, I have an x minus 2 on top, x minus 2 on the bottom, later. So I'm just left with a 3x minus 1. Whoops, there it is. Over here, I multiply by x minus 2 over 1. There's nothing to cross off, so I take the 3 and multiply it by the quantity of x minus 2. That's why I got it right there. This here, I can cross off an x minus 2 because it's on top, and an x minus 2 because it's on the bottom, and I'm just left with an x. Notice, I didn't say this in the last example, but notice, now my equation has no fractions in it. Oh, that's so nice. So I have an equation here with 0 fractions. So now all I got to do is solve it, like we did many classes prior to this video. So let's distribute if I can. I can right here. 3x minus 6, that's why it says that right here. Right there. And then I just combine my like terms. I have some on the same side, so I take the 3x and 3x and get 6x. I take the negative 1 and the negative 6 and get negative 7. So I'm out of like terms on the left side. I have only an x on the right side, so here's how I would do it. I would subtract an x here, get that guy over there, so it gives me 5x. And then I'd add a 7 to both sides, like that, which now I have 5x equals 7. Sweet. So then I would just divide by 5, divide by 5. Might not see that in the video, sorry. Which means I get the answer of 7/5. Bam. If I take 7/5 and plug it back in here, there's no 0 there in the denominator, so we're good. There certainly is, that's okay. If I put 7/5 back in here, phenomenal, there's no 0 in the denominator. So that is your answer, x equals 7 over 5. Sometimes it happens that you get a decimal. Sometimes it happens that you get a nice answer like we did the last time. I think it was negative 4. How sweet it is to be loved by math. Woo. Okay, there you go. Rock and roll.